Imagine a home that's not just built on Earth, but on the Moon or Mars. Picture this: a 3D printed dome made from moon dust, equipped with airlocks, radiation shielding, and AI-controlled life support systems. It sounds like science fiction, but it's becoming a reality. Welcome to the fascinating world of space architecture, where the art and science of designing human habitats beyond our planet is taking shape. As we set our sights on the Moon, Mars, and beyond, the urgency for permanent, livable structures in space has never been greater. We're moving beyond temporary space stations to envisioning homes, research centers, and entire communities off Earth. Leading the charge are organizations like NASA, ESA, innovative private companies such as AI SpaceFactory and Bjarke Ingels Group. They're not just dreaming. They're creating blueprints for a future where we don't just visit other planets. We live there. But building in space is a monumental challenge. The conditions are harsh and unforgiving. On the Moon, there's no atmosphere to shield us from solar radiation or micrometeorites. Mars presents its own set of challenges. The air is thin, filled with toxic dust, and temperatures fluctuate wildly. Oxygen is non-existent, and if something breaks, there's no hardware store around the corner. Every design must be ultra-resilient, self-sustaining, and adaptable to these extreme environments. So how do we tackle these challenges? Enter 3D printing. Instead of transporting tons of construction materials from Earth, a costly and impractical endeavor, space architects are looking to use what's already available: regolith, the soil found on the Moon and Mars. Autonomous robots will land ahead of human crews, mining this regolith to 3D print habitat walls and structures. This method is not only cheaper and scalable, but it also eliminates the need for constant resupply missions from Earth. And the materials we're talking about are surprisingly effective. In lab tests, moon dust-based concrete has proven to be stronger than brick and offers better radiation protection than glass or steel. We're not just theorizing. Prototypes are already in existence. Take AI SpaceFactory's Martian habitat, for instance. This egg-shaped Martian home won NASA's 3D printed habitat challenge and is designed to maximize space while minimizing material usage, all while withstanding the harsh Martian climate. In Texas, Icon and Big are collaborating with NASA on Project Olympus, a real moon-based testbed using 3D printing and lunar-like materials. These aren't mere concepts, they're full-scale demonstrations of how we'll build once we land on other celestial bodies. But it's not just about the structures themselves, it's about creating a comfortable living environment. Space homes need to be psychologically supportive. After all, you can't just step outside for a breath of fresh air. Designers are focusing on natural lighting, soft curves, and even plant walls to enhance mental well-being. AI systems will monitor temperature, oxygen levels, and stress, while smart walls adjust lighting based on mood and time of day. Some designs even include virtual windows that simulate Earth landscapes to combat homesickness. Looking ahead, the vision expands beyond individual homes to entire off-world cities. The Mars Society proposes underground cities beneath the Martian crust, shielded from radiation. ESA's Moon Village concept envisions a collaborative lunar base for research, mining, and tourism. Even SpaceX is planning for a self-sustaining Martian settlement, complete with schools, parks, and factories. These aren't just dreams, they're backed by real engineering and funding. Interestingly, many of these innovations in space architecture are finding applications right here on Earth. Extreme environments like the Arctic and disaster zones are benefiting from these modular, energy-efficient designs. Think about shelters for hurricanes or refugee crises. These concepts are inspired by the very idea of living in space. So, when can we expect to see people living in these off-world homes? NASA aims to return humans to the moon by 2026 under the Artemis program, with habitats arriving shortly after. While Mars settlements may still be decades away, we're already laying the groundwork. By the 2040s, we could see the first long-term human presence on the moon, and by 2050, perhaps even on Mars. This isn't just about exploration, it's about survival. With challenges like climate change and overpopulation on Earth, space offers a new frontier and a chance to rethink how we live. Space architecture is not just about futuristic buildings. It's the key to expanding humanity beyond our fragile planet. So the next time you think about architecture, consider looking up. The next revolution in housing may not be on Earth at all. It might be waiting for us in the cosmos.